We were looking at different variants of the goods market model. We started off with a simple case where only consumption depends upon income. Then we talked about the case where consumption and taxes depend upon income. We looked at equilibrium income in this particular variant. Then we looked at how does the relation between taxes and output affect our multiplier. We did a mathematical comparison, and then we looked at the economic inclusion. And we discussed the concept of automatic stabilizers. We now want to look at another variant of the goods market model where consumption and investment now both depend upon Y. First was only consumption depends upon Y. The second variant was consumption and taxes depend upon Y. The third variant we want to look at is that consumption and investment depends upon Y. The idea is that why does investment depend upon why? Because firms would invest more if they expect high income and therefore high demand for the goods. So later in chapter 5, we will extend this analysis and also look at investment depending upon R, but here our focus is on investment depending upon Y. So our model is now C naught plus C1 Y minus T. So now we're still taking taxes to be exogenously given. We already discussed the implications of allowing taxes to depend upon Y. Now we just want to look at the implications of allowing investment to depend upon Y in addition to consumption. G is G bar. Now, as compared to our standard model where I was I bar, we're taking I to be B naught plus B1 Y, right? So now we can solve for equilibrium income exactly as before by setting Z is equal to Y. So the process is the same. You find your demand schedule, Z, which is C plus I plus G, and X is 0 in a closed economy. And then you just set it equal to Y and solve for equilibrium income here. We did this previously also. If you just go back right over here. So equilibrium output is where YZ, Z, C plus I plus G plus NX. So T is still T bar, C is C naught plus C1 Y minus T. Now instead of I is I bar, the only difference is now when you're finding the demand function, I will be B naught plus B1 Y. So it has an induced income related component B1 Y. G is still G bar and X is 0. So similarly before you find your demand schedule, the only difference being now instead of I is equal to I bar, we're allowing I to depend upon Y. And then what you do is once you have your demand function, you just set it equal to Y and from here solve for equilibrium Y. So the process is exactly the same of finding equilibrium, regardless of which version of the goods market model you're looking at. The process will be the same. The only difference will be the assumptions you make regarding the different components of demand. So using the same exact same procedure, we can solve for equilibrium income. Now let's see how does the relation between investment and output affect the value of our multiplier. Let's first do a mathematical comparison. Now our old expenditure multiplier when B1 is 0. So our multiplier, old expenditure multiplier when B1 is 0 is just 1 by 1 minus C1. The expenditure multiplier would be the change in equilibrium due to change in G bar, due to change in B naught, or due to change in C naught, right? That would be our expenditure multiplier, which would measure how equilibrium income changes due to change in autonomous consumption, autonomous investment, or government spending. Right. So our old expenditure multiplier was 1 by 1 minus C1. New expenditure multiplier when B1 is not equal to 0 would be 1 by 1 minus C1 minus B1. Now, if we do a mathematical comparison, so we can see the denominator of the new expenditure multiplier is smaller than the denominator of the old expenditure multiplier. The reason is that B1 is greater than 0, right? B1 over here is greater than 0. So this means that basically what you're doing is from 1 minus C1, you're subtracting a positive amount. So that makes it smaller, right? Because from 1 minus C1, here now you're subtracting a positive amount. So that would make 1 minus C1 smaller because you're subtracting a positive amount from it. So the new expenditure denominator of the new expenditure multiplier is smaller than the denominator of old expenditure multiplier as B1 is positive. So from 1 minus C1, you're subtracting a positive amount, which makes the overall result smaller. Now, the numerator of both multipliers is the same one, but denominator of new multiplier is smaller. So the new multiplier is larger than the old multiplier. Because whenever you're comparing two fractions, if they have the same numerator, the one which has a smaller denominator, that fraction is going to be bigger, right? So because both of these multipliers, they have the same numerator one, but the denominator of the new multiplier is smaller. So overall, the new multiplier is larger. That's the mathematical comparison. That allowing investment to depend upon Y makes the value of our multiplier larger. Let's look at the economic intuition behind it. Now recall that in our standard goods market model, where we just had consumption as a function of income, we know multiplier exists because when income goes up, people consume more, which raises demand and income so that people consume even more. So if we go back to our mechanism of our multiplier effect, um, like this. This was a multiplier effect, right? We said, okay, when G increases, demand increases, that increases Y. But we said it doesn't stop here, because when Y increases, that increases C. And this was the beginning of the indirect effects of the shock. When C increases, that further increases demand. And when demand increases, that further increases Y. And this process keeps on going, right? So the reason the multiplier effect existed here was because C was a function of Y. So when Y went up, the result did not stop there. The increase in Y increased C, which further increased demand Y, and this process went on until we reached the equilibrium. So in addition to the direct effect of the shock, we had indirect effects of the shock because of the fact that C is a function of Y. Because here when Y increases, the process doesn't stop there. That increases C, which further increases Y, and this process keeps on going until we reach the equilibrium. Now in this model, not just C, now in this model that we have not just C, but investment also depends positively on Y. So after a positive change in autonomous spending, like for instance, a change in government spending, change in autonomous consumption, change in autonomous investment, when Y increases, now that doesn't just increase C, but investment also increases because investment is a positive function of Y now. So now you have a multiplier effect through two channels, consumption and investment, and not just one. So that's why the multiplier effect is largely intuitive. Because now when Y increases, now not just C increases, but investment also increases. So then demand increases by more, so output increases by more. So the multiplier intuitively is larger now because the multiplier effect is working not through just an increase in C now, but also through an increase in investment. So you have two channels through which the multiplier is working and not just one now. Because whenever now Y increases, after any positive change in autonomous spending, in this case, say G, it could be although a change in autonomous consumption, autonomous investment also. When Y increases, now the indirect effects of the shock will be because of not just the fact that C is increasing because of the increase in Y, but also because investment is increasing because of the increase in Y. Right? So whenever Y increases, C will increase, plus now investment will increase. And when C and investment both are increasing, demand will increase by more. When demand increases by more, output will increase by more, and that will again increase both investment and consumption. So the multiplier effect in this model, where investment is a positive function of Y, is larger because now the multiplier effect does not work just through C as it did in our simple model in which only C was a positive function of Y. But now because investment is also a positive function of Y, so whenever Y increases, C increases plus investment increases, that makes the multiplier effect larger. So in a simple goods market model, where only C is a function of Y, the multiplier effect works through C. But now when you allow investment to depend positively on Y, the multiplier effect works through two channels now, making the multiplier effect larger.